Hockey is a game of physics. Let's take a look inside the physics involved with the simple skills of hockey. When making a pass in hockey, the puck will follow a linear motion path. Since the puck stays on the ice and just moves in the horizontal plane, keep in mind that demonstrating passes on the concrete will not show the full effect of on-ice passes because of the difference in friction. The receiver of the pass will bring back their stick when collecting the puck. This will reduce the force of the puck on the stick by increasing the displacement. This is because the work the puck did would be equal to the kinetic energy because of the law of conservation of energy. Also, a hockey stick is designed to automatically flex at an impact, increasing the displacement automatically. When we take an inside look at shooting, we will see that the puck becomes a projectile and will follow the laws of projectile motion. Also, we see here that the hockey stick works as a third-class lever. The fulcrum point is the top control hand on the stick, while the force is being applied in the middle by the bottom hand. The load is the puck at the end of the stick. Notice how the wrist shot, meant for accuracy and not power, is taken differently than the slap shot, the shot made for power. In the slap shot, the bottom hand is moved lower on the stick to get a higher range of motion. Applying the same force with a higher displacement will increase the work that is done, therefore creating a higher kinetic energy and a higher velocity. Just how high of a velocity is Jacqueline shooting at? To figure out the velocity of the shot, we have to find the initial velocity in both the horizontal and vertical planes. She was shooting 6.91 meters away from the garage, and her shots consistently hit the garage door 0.81 meters up. We timed how long it took the ball to travel and discovered that it was 0.38 seconds. After making our table of what we know and what we are trying to find, it's time to plug them into the equation. Using just displacement and time, we can find the horizontal velocity of 18.2 meters per second. Assuming the vertical acceleration is the rate of gravity, negative 9.8066 meters per second squared, we can rearrange change in y equals v naught t plus 1/2 at squared to plug in all of our data and get a total vertical initial velocity of 4.0 meters per second. In order to find the velocity of our shot, we can use Pythagorean theorem. Jacqueline shoots the puck off carpet at 18.6 meters per second. In order to show the proper form of different shots, we had to lay down carpet in order to allow the puck to move along better. The coefficient of friction on ice is very low. Unlike walking, where you use friction to move you forward, you have to provide your own force to begin skating. A person needs to dig in the edge by angling their skates in order to provide a force you need to move. Then fluid friction takes place, as the material of the skate blade melts the ice. We did an experiment to discover the effect of one's mass on the ice while skating. I have a higher mass than Jacqueline. We both skated at the same velocity and then started just gliding, applying no force until we stopped. In 3 trials, Jacqueline and I went the same exact distance. Besides finding out that people would judge us for doing this in public, we also discovered that the mass of the skater doesn't matter on the ice. A final skill of hockey would be checking. I cannot demonstrate a check because checking is not allowed in girls hockey, but let's take a look at the pros. Checking involves momentum and impulse. Since the conservation of momentum exists, the momentum done by the checker will transfer to the person being hit. Therefore, they will each have the same change in momentum or impulse. The person making the hit will have a longer time to provide that impulse, meaning that the force they feel will be smaller. The person taking the hit will only have a smaller time, being stopped by the boards or the ice, receiving a bigger amount of force. Next time you're watching hockey, instead of waiting for all the fights, think about the physics that is involved with every simple skill.